In this video, we're going to start section 7.2, which is titled Describing and Analyzing Data. So really what we've been looking at in chapter 7 is statistics. And let me define statistics for you. Statistics is the science of collecting, organizing, summarizing, and analyzing data. Now, some definitions take this a little further and say that the purpose really is to make predictions or good observations of the data. Now, based on this definition and my knowledge of statistics, I actually really hate the title of this section. We are most definitely not analyzing data. Analyzing data requires quite a bit of statistics and understanding of probability, which we won't even cover until the next chapter. So we aren't really analyzing data. We are more describing data. But in this definition, what we're really doing is going to be looking at summarizing the data. So last section, we organized data into graphs. This section, we're going to be looking at summarizing data, and it can be used for analyzing, but we don't really do much of that in this. Okay, now in statistics, they kind of do have two basic areas that are covered. There is what's called descriptive statistics. And in descriptive statistics, that's really where you do the collecting, organizing, and summarizing. And collecting data is something we also haven't really talked about, about how to properly get data from populations you're interested in, sample size, what's appropriate, and all of that. So we haven't really talked about that. We've really only looked at organizing, and now we're just going to look a little bit at summarizing. Inferential statistics is the part of the statistics that takes the analysis and applies it. So this is when you do the analyzing portion. And it's really for the purpose of applying it to make predictions or kind of see what the trends are within a population. Okay, so there you go. That's kind of the general gist of what we are doing right now. So in this section, we're going to be focusing on summarizing data. And we kind of do that with two basic methods, but we'll be also kind of taking a break and introducing a third topic that does go with it. So first thing we're going to look at is what's called central tendency. Central tendency is really looking at the center of the data. Now that can be the literal center, but it could be like something that represents the center. The word we typically like to use in everyday talk is average. Now, most people, when they think of average, they think of adding the data up and dividing by how many pieces of data there are. That's actually one type of central tendency called the mean. So the mean is what we often call the average, often called average. This is what most people think of when they hear the word average. And to find it, you sum the data and divide by the total number of measurements. How many pieces of data there are. All right. Let's look at an example. So let's say you did a survey of 9 students and found that the time it takes to get to OCCC is, oh, in minutes, sorry, in minutes is 11, 6, 20, 11, 45. Oh, I'm sorry, 48, not 45. I apologize. 48, 17, 29, 18, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good. Got them all written down. So let's say we want to find the mean. Okay, so I'm going to add these all together and divide by 9. I would like you to show me some work. So a couple ways you can do that. You can literally just show me that you're going to add these all together, which is a good option. And then we're going to divide by 9. Or you can show me the sum when you add them all together. So go ahead and add them all together in your calculator. I'm going to do the same. 48. Sorry, talking to myself while I'm doing it. And I get 170 when I add them all together. And so I'm going to take that and divide by 9. And that gives me 18.9, which I guess if I wanted to, I could just round that to 19 minutes, but that's okay. Typically, when we get this mean, we're okay with decimals. We understand that it may not be an answer somebody's going to necessarily give, right? Most people are not going to say, I traveled 18.9 minutes, but we get it. It's a decimal because we're using all of the data to find it. Most people love the mean for that reason, by the way, the fact that we used all of the data to find the value. It just feels somehow more appropriate for measuring everything. And it is a great option when it can be used. But there are some cases where it can't be used, and we'll talk about that when we look at other types of central tendency. Before I do that, though, I want to point out that there is a formula for the mean. And it uses this label for the data. So you would say the data is x1, x sub 2, x sub 3, meaning first piece of data, second piece of data, third piece of data, dot, dot, dot. And it keeps going until you get to the last piece of data, which we'll call x sub n, where n is representing how many pieces of data we have taken, n people or n measurements or something like that, okay? And the formula itself is x bar, so x with a bar over it, equals x sub 1 plus x sub 2 plus x sub 3 plus, and you keep doing this pattern until you get to x sub n, and then you divide by the total number of data pieces, which is n, and that gives us the mean. So we use this symbol, x sub bar, to represent mean. So up here, I'm going to go ahead and apply that label, x sub bar then equals 18.9 minutes, just so I kind of see it in action. And just so we're clear, this would be x sub 1, x sub 2, x sub 3, right? And our n in this problem is 9 because we have 9 pieces of data. So if I kept labeling everything, the last piece of data I would have is x sub 9, because that's what n is for me. Okay, so just so we're clear, they do have that formula, and I want us to understand what it means. What it means, get it? Okay. Median, that is the second type of central tendency we'll look at. To find the median, you put the data in order. And what I mean by order is smallest to biggest, okay? To find the middle value. Now, if you happen to be working with an even number of data values, so if there is an even number of values, take the middle two, or take the average. No, sorry, I won't use the word average. Take the mean of the middle two. So you take the 2 in the middle, add them together and divide by 2. That's what that means. Okay, now median is really good for data that might have an outlier. Most of us have heard that phrase before, an outlier. An outlier is a piece of data that doesn't really match everything else or the expectation of data. It's possible that we have somebody traveling to the college who's coming from Corvallis. That person's commute time is going to be way longer than everybody else's. Is it likely? No, but it is possible. And therefore, that person would be an outlier. Okay. So outliers exist. It's not like they can't happen. They can. They're just not as likely to happen. And they don't always show up in every sample that you look at. Okay. All right, so let's do the median for the same commute time. Okay, so find the median for commute times. Wow, that's not how you spell commute. Oh, wait, no, it is. Just kidding. I said that with so much confidence. Commute time. There we go. Okay. Or hip times. So I'm just gonna pull up here and look at the data here. So we're referring to this data and we want to put it in order. Okay. So that means and you may want to take a second, pause the video and put the data in order. Okay. But I'm gonna go ahead and do that as I go because I've already done it ahead of time. Isn't that amazing? Okay. So here we go. 6 is the smallest one. Oops, I wanted to use green. I started writing before it was ready. Followed by 10, 11, 11 again, 17, 18, 20, 29, and 48. And there we go. Okay, so there's my data. And I put it in order. And since there's 9 data values, that means I will have a middle value. So if I kind of count on either side, right? 1, 2, 3, 4. 1, 2, 3, 4. There it is. That's the middle. There's the median. Some people use a capital M to represent the median. Some just say MED. But it doesn't have kind of like the special symbol that the mean does, because the mean is the one that is preferred if we can use it. All right, but the median is useful, and we'll see that actually. Okay, the next type of central tendency, and hopefully you kind of recognize the mean, median. Third is mode. I hope you've seen these 3. So the mode is pretty simple. The mode is the most frequently occurring value. Occurring data value here. I'll use that phrase. And here is what the mode is useful for. It's really useful for categorical data. So when we're talking about non-numerical data, the mode represents what we call the central tendency because it's telling us the most frequent group, the answer that most frequently comes up. And it's a way of us kind of looking at the data and saying, oh, okay, so when you ask everybody their eye color and brown pops up, brown must be the dominant eye color. And it is. Okay. On average, that's most people's eye color. It's also really useful for comparing. And we kind of use it in that range. Because once you're looking at categorical data, all you're doing is saying, okay, so the most frequently occurring group is the mode, and you're done. But for when you're looking at the mean and the median, finding the mode is actually really useful for being able to tell information about the data. Now, because we're not going to be analyzing, we're not really going to get too much into that, but that is one of its uses. Okay, so let's go ahead and find the mode for our commute times. Wow, there's no E on there. Find the mode for commute times. And that's actually really easy. I'll just use what I have written above in green. I clearly see that 11 is repeated twice, so 11 minutes. All right, and there you go. That's how we find the mean, median, mode. Let's go ahead and do an example where we just find all three. So let's find the mean, median, and mode. For, sorry. Oh, for children's heights in centimeters. Children's heights in centimeters. Ooh, I do want to pause here for a second because I just realized I forgot to mention. It's possible to have more than one mode, okay? In fact, sorry, I'll come back up here, and if you can squeeze it in, I'm so sorry. I should have put that up there. It's possible to have two modes. If you have two modes, they call that bimodal. Okay. Three modes is trimodal. And then anything more is multimodal. Okay. So 4 or up is what we call multimodal. And then, of course, it's also possible not to have a mode. That's a possibility too, okay? So for the reason that we're working with numerical data, the mode may not be the most reliable thing to look at, but if we can include it, it can be useful. Okay, sorry, I meant to mention those labels. So trimodal, bimodal, multimodal, or no mode at all is a possibility. Okay, so here we go. Children's heights in centimeters. Let me go ahead and return to this. So we have 129, 124, 123, 129, 126, 124, 125, and 126. Okay, so let's start by finding the mean. So I'm going to use that symbol X bar to represent the mean. And I'm going to go ahead and total these all up. I like to write it down. I just think it's nice to see the steps that I'm taking, even though I'm going to do it in the calculator. 125 plus 126. Okay, and let's see. I have 1, 2, 3, 4, 5, 6, 7, 8 children here. So I'm going to divide it by 8. And I ended up getting 1006 divided by 8, which comes out to 125.75 centimeters. Okay, let's find the median. So for the median, I'm going to want to put the data in order. So smallest value is 123, followed by 124 twice. Here, I'm going to try to keep track. There we go. That's better. All right, 125, 126 twice, and then 129 twice. Okay, now this one, 1, 2, 3, 4, 5, 6, 7, 8. Okay, good, I got them all. Is an even number. Therefore, it's the middle two I'm going to look at, which is these two, 125, 126. So to find the median, I'm going to go ahead and add them together and divide by 2. 125 plus 126 divided by 2. And that comes out to 125.5 centimeters. And having them listed out like this actually makes the mode really easy to see. And there are 3 modes. Yeah. So let's see. 124, 126, 129. So there we go. We'll list all 3 of them. And you can kind of say, well, in the middle of them is 126. And that kind of matches what we got for the mean and the median. Both of those, if you rounded it, would round to 126. So they're all kind of consistent. But it doesn't really matter in this. It's okay. We'll list all 3. And it just gives us a snapshot of what's going on with the data. And that is what we kind of do for finding the central tendency.